A v rýchlosti blesku uvediem Martina Odstrčilka. Vítame od Labyrinth Labsov, bratislavská firmička, spústa zaujímavých technológií. Tak a Martin nám bude teda rozprávať o tom, ako by postavil nejaké škálovateľné SaaS-ko s tým, že bude dynamicky provižnovať tenantov. Takže sa na to veľmi teším. Prezentácia bude v angličtine. Martin je z Brna, ako som sa pred chvíľkou dozvedel. Pracuje remote a má rád spústu vecí okolo Kuberneta, ale to je samozrejme tu už dosť jasné u všetkých. Používa superkultúry ako Terraform, čo všetci máme veľmi radi, že jo, servisnú mež a hromadu vecí okolo toho. A okrem toho, ako správny český občan, má rád pivo a metal. Takže teda nebudeme to naťahovať a dávam slovo Martinovi.
Okay, so hello everybody, and welcome to a talk from the series Building a Scalable SaaS. This time we will be looking at dynamic tenant provisioning with focus on Argo Workflows. We have chosen for this scenario. My name is Martin Odstrcilik, and I am one of the folks from Labyrinth Labs, which is a local company from Bratislava, but with a global reach, focusing mostly on DevOps services, cloud, and especially Kubernetes. We are on a mission to help our customers on their journey to the cloud by either accelerating startups to get them to the market sooner with their product, or helping scale-ups migrate to the cloud and be able to scale there without breaking the bank. Let's start with some theory. I know, and I'm sorry, but I would like you to be on the same page when I will be talking about multi-tenancy and referencing isolation concepts. So basically, we choose between a silo and a pool model, where silo means that every tenant has all resources just for himself. This is good for strong isolation, but comes with a price, meaning dollars. On the other hand, we got a pool model, where everything is shared between individual tenants. Obviously, this would be a cheaper solution than the silo, but comes with challenges like noisy neighbors. And there is also something in between we can call a bridge, which basically is something from both worlds, let's say. So you can have a shared front end or back end, and then siloed database or storage, or vice versa. And another takeaway from this slide is that the isolation model should be evaluated or decided individually for each component of an application. And by having a multi-tenant application, regardless of an isolation model, and we can call it application plane, you might be missing a few things to have a proper SaaS service. SaaSification of your application will help you to operate it faster from business point of view. For example, by having tenants to have a self-service or to have some meaningful tenant insight for the business. So in order to have that, you will need some kind of control plane to provide you functionality like onboarding and offboarding the tenants, tiering, billing, etc. And we are done with the boring stuff. And to set a landscape for this talk, I would like to introduce you a customer. So this customer sells agent-based software for providing customer support. You can imagine that you go to some website and there is that button in the right bottom corner. You click it and you have that chat window. You can talk to support for the website. It's a large-scale company with thousands of existing users. They have fully pooled multi-tenant application. and they already have a SaaS offering. Also, they are simultaneously running and supporting more application versions. And the tenant management is handled by some core CRM system. This is the control plane I talked about. So everything is okay, right? So what's the problem here? Where they got real legacy setup and a huge technical debt. And everything is running on on-premise data center. That means that they have, unfortunately, a lot of reliability and scalability issues. So they have come to us. And we came with a plan, migration plan to the cloud, obviously. So onward, we say. So let's have a look how the migration looked like. So when we migrated the databases, we actually did some kind of lift and shift, some replatforming, let's say, by just moving the databases from on-premise VMs to AWS EC2 instances. You might be wondering why we didn't choose to run that on some managed solution from the cloud provider, like RDS. Well, the customer already has in-house team with a deep knowledge of database management and operations. And also with their scale of the databases, talking about several cores, even more memory, and terabytes of data, is not cheap to host managed database like that in the cloud. So we basically went this way. It was a better decision for them. They started with a monolithic application, and they were on a transition to microservices. And as we focus on that, and it's a fit for this use case, we decided to move the applications from the VMs to the Kubernetes. Also, they were managing or hosting the DNS services on their own, on their VMs. And this is kind of danger zone, so we really pushed them to try to use some managed service from AWS, like Route 53. And this was one of the more interesting aspects of that migration, because with thousands of tenants, if you basically create for each tenant individual zone, that comes with a price. So we were looking in the option to basically put every tenant records into a single DNS zone, which is basically fine from the Route 53 perspective that can scale like hell. But what about other related services that runs in the Kubernetes? For example, Cert Manager for issuing certificates, or external DNS control that manages that zone. There were some pitfalls to that, and we can talk about that later. Also, the client has few caching layers, so we put traffic caching into AKS next to the ingress controller, and then for application caching, we choose managed service from AWS Elasticache for Redis. Previously, they managed the infrastructure kind of manually, so when they wanted to have another VM, they come to a portal from this provider, created that VM manually, and then run SaltStack component to do the provisioning. That's not a scalable solution, so we went through introducing infrastructure as code by using Terraform, and we kept SaltStack for provisioning those VMs because that's just fine, that fits. Another interesting point of that migration was that we needed to exchange NGIX proxy for Traefik. And the reason for that is when you have a really large volume of requests per second, and you do the configuration change often, how the NGIX behind the scenes does that is that it spawns new processes, but keeps the old ones until the requests are finished. And you might guess what could happen in that case. Anyone? Well, I will help you out. Basically, this will eat all the memory on the node, so the node will be basically doomed. Traefik doesn't suffer from this. There's different architecture behind the scenes, so it works just fine in this scenario. Also, as I mentioned, we were migrating from VMs to Kubernetes. We needed to change how the application is deployed. So we went from some custom archive and custom deploy scripts to container images, GitOps pattern using Argo CD and Helm for the packaging. And now we came to the tenant provisioning. So they used SaltStack basically for everything. And it's not just good fit for Kubernetes world. So we needed something else in that area, and we have chosen Argo Workflows. Now we will have a look how a tenant lifecycle could look like from tenant provisioning perspective. You have several stages, like onboarding, which translates into provisioning some resources. Then you might want to have some kind of migration, either moving the tenant from one region to another. Or, in this case, we wanted to somehow capture the scenario of migrating the tenant from on-premises to the new cloud environment. Also, typically, you have some configuration changes or version changes on the tenant side. And when, unfortunately, you need to offboard the tenant, you might either suspend its subscription or do a complete removal, which will also unprovision those resources. So we will have a closer look on the tenant onboarding. So the customer, the tenant, comes to the website and he will sign up for some subscription plan, let's say. That information will be written into the CRM system, and the CRM needs to conduct several steps in order to onboard the tenant. So it will invoke a workflow. Workflow will orchestrate tasks like creating DNS records, spawning some Kubernetes resources like ingress, service, config maps. And it will also offload tasks like database schema provisioning to the SaltStack. While all this is happening in the workflow, CRM is polling the workflow for its status. And once it finishes, it will notify the customer that his account is ready to use. And onboarding is done. Excellent. So for the workflow piece, we have chosen Argo Workflows, as I mentioned previously. And what it basically is, it's a bunch of CRDs in the Kubernetes and a controller that reconciles them. And there is a UI and API layer. And from the tenant perspective, here I got some neat features of Argo Workflows, and I will be talking about them later on in more depth, but we will be looking at supporting passing and storing artifacts. It can handle complex and parallel flows. It has built-in retry and limit mechanism and capabilities to create Kubernetes resources. And also it comes with the Kubernetes native secret handling. So when you want to submit a workflow into Argo Workflows, you will create a workflow with capital W. It's a CRD in Kubernetes, and it will create an ephemeral instance of some workflow. But when you want to have that workflow and sit it in the cluster as an actual resource, you need to create a workflow template, which is a reusable definition of a workflow. And in that case, it could be invoked directly or be part of another workflow, so you can achieve some kind of composition. Also, it can be versioned and deployed in GitOps way, meaning that it sits in some Git repository, and then you can have Argo CD to manage the lifecycle of those templates. When you are onboarding a tenant, you will want to pass some data to the workflow, like tenant ID. And you can have inputs either like globally available, or you can have, in that case of the workflow template, and you can see that on the right, that you basically saying in this template that your workflow or your task actually requires on input some parameter with a name of template ID, and then you can rely when this task is invoked that someone needs to pass that tenant ID. When you want to pass data between individual steps of a workflow, you can do that by specifying output. So you can have a step in your workflow that generates some, for example, some configuration file, and then have another step that will consume it. And if you want to share the data between workflows, or the data is complex in some way, you can use artifacts for that purpose. You can persist those artifacts in some blob storage, can be S3 bucket, and other blob storages you can imagine, like Minio. And then you can fetch those artifacts. It could be other things as well, like some data sets or binaries. And also it can be used for caching, so you can improve the performance of your workflow. If you have a complex workflow, or you want to maximize the throughput by running tasks in parallel, you could use directed acyclic graph, DAG, to order tasks within the workflow. So on the right side, I have an example how that would look like in Argo Workflows notation, and it's basically a diamond. So the workflow starts with the task A. Once it finishes, B and C will run in parallel, and once those two tasks are finished, then the D will be executed. You can also have multiple routes with DAG in Argo Workflows. There's the example with A and B on the same level. And also the Argo Workflows has built-in mechanism for failing fast. So A and B is executed in parallel, but B fails. That translates to using the fail fast feature that C won't execute. And question for you, what will happen with D? Will it execute or not? Excellent. 1 point there. Okay. Moving on to secrets. So for sure, when you are running a workflow and you are doing some kind of provisioning, you will need a secret to access the database, for example, or call some API. And Argo Workflows has the same secret syntax like Kubernetes pod. So you can inject secrets into Argo Workflows workflow by specifying some environment variable or use files through volumes. This will also help you to store secrets in some cloud-native storage, for example, AWS Secrets Manager, and you kind of have an assurance that that secret is safe because it's encrypted, and you can also leverage capabilities like rotation of those secrets. And then you can use external secrets controller on the Kubernetes side, which will do the heavy lifting for you, and it will sync the secret from Cloud Native Store into Kubernetes secret, and then you can use it as you like. Also, Argo Workflows has direct support for creating Kubernetes resources. So instead of running some Helm or kubectl within the workflow, you can leverage this built-in mechanism, just specify the task that will either create, delete, apply, or patch Kubernetes resource. In this case, we are creating ingress resource that will be used for ingress path for a tenant. When you create a resource like this using Argo Workflows, it will outlive the workflow itself, so it will stay in the cluster. And if you, for example, are creating some Kubernetes job, you might want to have to be garbage collected once the workflow is deleted, so everything will be cleaned up in that case. And if something goes wrong, there is a built-in mechanism for doing retries in, let's say, clever way, using a backoff mechanism. But you need to make sure that when you are repeating those tasks in the workflow, they are idempotent, meaning that when you run them again, and if they succeeded or failed in the previous run, if you repeat those, the result will be the same without any side effects. It's really important because otherwise you will be including more errors into your workflow. And also, Argo Workflows can be integrated with outside world. In our case, it was that core CRM system. So you can leverage some REST API for common use cases like creating the workflow, deleting, or polling its status. And it can act in a reactive way using events API. So you can set up some external webhook that will be called when something happens, and it can trigger some workflow template for you. And for the end of the presentation, I have some hypothetical slide. Let's say, what if this would be a greenfield project? So without any legacy, we'll be building this on a completely greenfield. In that case, you might replace Argo Workflows with a different technology. That one is called Crossplane. And anyone knows what it is? So Crossplane is basically Terraform within Kubernetes. So you can create some cloud database like AWS RDS by just specifying Kubernetes resource with some proper CRD from the Crossplane. And from that point on, Crossplane will manage this resource lifecycle. So Crossplane basically can serve you as that universal control plane, be Kubernetes native, and you can use it to either create resources or write your own providers, do composition there, and have everything managed from within to Kubernetes. So have the replacement for the CRM system. Cool. So, and that's it, folks. So now over to you, and if you have any questions, I would be real happy to answer them. So thank you.
Thank you for the presentation. And yeah, let's just divide the messages. So we have like nothing in the Slido. So any questions in the audience?
Am I allowed to ask questions right now? Yeah.
Yeah, sure. Go ahead.
Oh, thank you.
Anytime.
I was really interested. Yeah, in you've mentioned the fail fast features. Yeah, in Argo Workflows. But I'm interested. Is there any abstract for kind of try, catch, and finally logs like from the box? So if, for example, you fail fast somewhere, but you still need to clean up resources to get logs and whatever.
Yeah, there is a mechanism, they call it exit handlers. So it's like they are executed at the very end of the workflow, and you can do things like cleanup or even leverage those to send some kind of notification. So yeah, there is concept like that.
Yeah, thank you.
Any other question?
I can ask one more.
Go ahead.
Let's split it into two. So first, I'm interested. How long does this migration took, and what was in the middle of the migration? So have you like supported two ways like simultaneously via like kind of traffic load balancing, or it was like big bang from like blue green or something?
I will be completely honest with you. That migration is still happening. So the migration plan I showed you, yeah, we are in the process of it. So there could be a separate talk on that topic for sure, but yeah, there are like the general theme is that we are like doing migration in steps. So basically migrating one tenant at a time, because also it means that not every tenant is, let's say, have the same size in terms of the database schema and so on. So there are some critical ones. So yeah, it's a tenant per tenant base migration, not a big bang. And also an interesting fact is that we are planning to run those infrastructures simultaneously. So something will run from the new infrastructure and something will run from the old one.
That was so you plan to load balance the traffic
Yeah.
instead of
Yeah.
Okay,
Yeah.
cool. That's fine. Yeah.
I have one question, if I may. Are you using all the other clouds or just AWS?
We are focusing mostly on AWS because we have a really good relationship there. But we also have few customers that have some workloads in Azure, somewhere maybe a GCP.
You mentioned that new tool that you would use if you would be on greenfield deployment. Is it does it have any benefits compared to what AWS provides as their like services for deployment and workflows?
Well, we are building, or the central piece of our work is often Kubernetes. So it's kind of like you have basically the same offering from all those three major cloud providers in terms of Kubernetes. So from that point, it kind of doesn't matter. It's about that, in this case, the customer was already using some AWS services like S3 and some databases. So it was kind of natural to go this way. And as I mentioned here, we can like help the customers to grow in AWS with our partnership with AWS. So
Yeah, but the tool you mentioned on the last slide, I forgot the name of it.
yeah, it was a crossplane. That's open source thing. It doesn't relate to any cloud provider.
Yes, but like AWS has something which has the same functionality or not? Or what's the benefit of that crossplane?
Yeah, well, I think that even like there are operators for Terraform as well, and definitely there are other ways how to achieve the same functionality as a crossplane. I mentioned crossplane specifically because we used it in with other customer on the similar scenario, and it was a better fit than Argo Workflows in their case. So that's why I mention it as a basically an alternative to Argo Workflows for dynamic tenant provisioning.
How you are managing the releasing of the workflows? If you are developing new versions?
Yeah, so everything is stored in Git, and there is like those workflows will be bundled in a Helm chart basically, and that comes with some versioning on its own. So you can release some Helm release, and you are sure that you are on that version. And we will try to either do a backwards compatible changes, and if not, then we will probably put some versioning in the name of the workflow. So when there will be some kind of like new lifecycle operation, then it will call something different.
Have you tried Argo CD for this?
Yeah. Yeah, we are using that for application deployment.
Yeah.
And as I mentioned, if you have this workflow template, which is Kubernetes resource, it can be deployable by Argo CD as well.
Yeah.
So yeah, we are embracing the GitOps pattern.
That's cool. And all your customers, can they utilize everything that Kubernetes is able to bring them, or is this just a too big solution for some of your customers, so maybe you could utilize like ECS or something similar?
Yeah, we have several, let's say, cases when actually the customer wasn't satisfied with the ECS because it lacked some functionality. Yeah. So we help them to migrate to Kubernetes. Basically, even if this is a startup and they are building something up from the beginning, we go straight to Kubernetes because it enables you to grow better than than the ECS. You had a question? Yeah, sorry.
Customers are on the same cluster, or you have multiple Kubernetes clusters?
Actually, yeah. With this customer, those tenants are across the whole globe. So there are multiple clusters in different regions. But there, in each individual region, there is one production cluster. Because that application is multi-tenant. The multi-tenancy is already built into the application, so we don't need multiple clusters.
One more question about the crossplay. So as far as I got, in scope of your presentation and your design, it may be used instead of Argo CD, CI/CD like workflow, that you need to do something on top of Kubernetes cluster. But also I saw and read some newspapers about it actually be compared to the Terraform to store kind of infrastructure as a code. So for example, if I want to have my desired state in Kubernetes cluster, can I use this tool to just reconcile this desired state constantly?
Yeah, you can. No. Yeah, the crossplane basically uses the reconciliation loop that is built into the Kubernetes. So the crossplane also comes with a bunch of CRDs. And so you specify a resource for the database, and when that, like, I don't know, it's RDS cluster, let's say, that's the name of the resource. And basically when there is a change in the manifest of this resource, it will, like, Kubernetes will notify the crossplane controller, and the controller will deal with the reconciliation of that, like resource, what should happen, what the change would be.
One other question. In the end, when your customer is like fully migrated into the Kubernetes cluster, are you using the cluster itself for the customer, or is it like a job for you to like migrate them and just like let them go and use it?
It can be both ways. It depends on the customer, and I'm not sure if I can disclose this information for this customer. But we usually the customers stays with us for long term, and we help them to manage their infrastructure in some way.
So with crossplane, if you keep the configuration in crossplane and you need to do a change, you always have to do with crossplane, and you can't use AWS console anymore. So because if you change something there, the control plane will change it. So
yeah, it's the same thing with the Terraform. It handles the lifecycle of that resource. So if you do that change externally, then on the next run of the crossplane reconciliation loop, that change would disappear.
But the control plane runs like periodically, or
yeah,
you have to run it like manually?
No, it runs periodically. Or definitely you can, on the crossplane level, you can like choose how the crossplane should behave in that case. Like typically with Terraform, you need to introduce some kind of automation on top of it if you want to have some automatic reconciliation. The same could be achieved with a crossplane, and I would believe that the default behavior is that the crossplane reconciles that automatically. But I think you can opt out from that.